बच्चों अब मैं फिज़िक्स के चैप्टर नंबर 3 करंट इलेक्ट्रिसिटी की एनसीईआरटी में से समरी पढ़ूंगी। Current through a given area of a conductor is a net charge passing per unit time through the area. To maintain a steady current, we must have a closed circuit in which an external agency moves electric charge from lower to higher potential energy. The work done per unit charge by the source in taking the charge from lower to higher potential energy, that is from one terminal of the source to the other, is called the electromotive force or EMF of the source. Note that the EMF is not a force, it is the voltage difference between the two terminals of a source in open circuit. Ohm's law. The electric current I flowing through a substance is proportional to the voltage V across its end, that is V is directly proportional to I or V is equal to Ri, where R is called the resistance of the substance. The unit of resistance is ohm. 1 ohm is equal to 1 volt per ampere. The resistance R of a conductor depends on its length L and the cross sectional area A through the relation R is equal to rho L upon A, where rho, called resistivity, is a property of the material and depends on the temperature and pressure. Electrical resistivity of substances varies from over a very wide range. Metals have low resistivity in the order of 10 raised to the power minus 8 ohm meter to 10 raised to the power minus 6 ohm meter. Insulators and like glass and rubber, they have 10 raised to the power 22 to 10 raised to the power 24 times greater resistivity. Semiconductors like silicon and germanium lie roughly in the middle range of the resistivity on a logarithmic scale. In most substances, the carriers of current are electrons. In some cases, for example, ionic crystals and electrolytic liquids, positive and negative ions carry the electric current. Current density J gives the amount of charge flowing per second per unit area normal to the flow. Uh, J is equal to NQVD, where N is the number density, number per unit volume of charge. Carriers such as the each of charge Q and Vd is the drift velocity of the charge carrier. For electrons, Q is equal to minus E if J is normal to the cross sectional area A and is constant over the area. The magnitude of the I through the area is given by NEVDA. Using E is equal to V upon L, I is equal to NEVDA, and in Ohm's law one obtains EE upon M is given by rho and E ka square upon M VD. The proportionality between the force EE on the electrons in a metal due to the external field E and the drift velocity Vd, not accelerated, can be understood. If you assume that the electrons suffer collisions with ions in the metal which deflect them randomly, if such collisions occur on an average at a time interval tau, then Vd is equal to A tau is equal to E tau by m, where A is the acceleration of the electron. This gives rho is equal to m upon n e ka square tau in the temperature range in which resistivity increases linearly with the temperature. The temperature coefficient of resistivity alpha is defined as the fractional increase in resistivity per unit increase in temperature. Ohm's law is obeyed by many substances, but it is not fundamental law of nature. It fails if V depends on I non-linearly. The relation between V and I depends on the sign of V for the same absolute value of V. The relation between V and I are non-unique. As example of A is when rho increases with I even if temperature is kept fixed. A rectifier combines features A and B. Gallium arsenide shows the feature C. When a source of EMF. E is connected to an external resistance R. The voltage V external across R is given by V external is equal to IR, and that is equal to E R upon R plus R, where R is the small r is the internal resistance of the source. Total resistance R of n resistors connected in series is given by R is equal to R1 plus R2, so on. Total resistance R of n resistors connected in parallel is given by 1 by R is equal to 1 upon R1 plus 1 upon R2, so on. Kirchhoff's rule, junction rule. At any junction of current elements, the sum of the currents entering the junction must be equal the sum of currents leaving it. Loop rule. The algebraic sum of changes in potential around any closed loop must be 0. The Wheatstone bridge is an arrangement of four resistors R1, R2, R3, R4 as shown in the text. The null point condition is given by R1 upon R2 is equal to R3 upon R4, using which the value of the one resistance can be determined knowing the other three resistances. The potentiometer is a device to compare potential differences. Uh, some the method involves such a method involves a condition of no current flow. The device can be used to measure potential difference, internal resistance of a cell, and compare EMF of two sources. Then there is a table given and all the physical quantities, their symbols, dimensions, unit, and remarks are given. First quantity is electric current, then charge, voltage, electromotive force, resistance, resistivity, electrical conductivity, electric field, drift speed, relaxation time, current density, and mobility. To learn this table and all the dimensions and units, then read points to ponder.